Hey, what's going on, guys? KIM-1 here. Probably you're already sick and tired of my KIM-1 related videos. So please let me make one last one. This would be a really short one, and hopefully starting from the next video we will already get back to chess programming topics. So recently I've been porting supermon64, which has a hex monitor for Commodore 64, to KIM-1, and I made a big video describing that process. But the downside of that version that I've been showing in the previous video was that it didn't have the feature of auto-completing the next line with address where the next instruction is supposed to be stored. So in the version I'm about to introduce in this video, that it has been already fixed. So the problem was that it was actually storing the next address into the keyboard buffer, but that was C64 specific memory location. So probably somehow automatically C64 has been appending this to the next line. However, in KIM-1 in a serial mode, this obviously didn't work. So here, instead of jumping to start, not even in the source code, but in the eventual binary kind of executable, I've made here in the eventual binary executable, I'll just replace the code that goes to the start. This is the start address 957A, and it goes instead to A008, and which is available here. And here I have my tiny little, so here it is, here I have my tiny little autocomplete routine. So literally what it does, it just prints a new line, prints dot, meaning that you're about to just continue your assembly code. It could have been printing like to the screen the address itself, but then when you hit enter, after you hit a complete line, it just stucks there, and it's not kind of doesn't look good. So I didn't like this. Instead of just this dot here. But the most important thing, that it actually writes this into the input buffer, so we can continue the next line without manually recalculating the address for the next assembly instruction. So without further ado, let's quickly build this. So make and origin 9548. So go in here, assemble 0x9548, and upload 9548 space Shift G, and we're in the monitor. So if I say like assemble, and then the address, let's say 30, and just whatever, like LZA 10 for instance, it assembles the line, and then this dot tells us that we're about to be continuing writing some assembly code. So for instance, I can say STA, and I don't know where, I'm not going to be running this one in particular, so let's say 3000 for instance. So say like it does assemble the next line, however it wasn't the case in the previous version. So if I hit enter again to get away from the assembly mode, and then M300, so inspecting the memory at 300, so we have exactly A9, which stands for LDA, immediate addressing mode, the value of 10, immediate data of 10, then AD, absolute addressing mode, to the address 3000, so to 3000 hexadecimal. So it has been assembled properly, which is good. So now let's write a simple program and run it from the hex monitor to complete this video. So I can say, for instance, again, I can just reassemble at exactly the same place. So I can say 300s, and I want to say jump to subroutine 1E5E. This is to get the user input from the keyboard where the serial port. All right. Then I want to say jump to subroutine 1E0. So this one is to output the character, and then I want to do this in the infinite loop. So I can say jump to 300s. So enter again to escape this assembling mode. So inspect memory at 300s. So yeah, jump to subroutine, get the character, jump to subroutine, output the character, and do this forever. So it just loops back to here. So if I did everything properly and press G and 300s to go to the 300s, so the stack pointer after this is going to be pointing to 300s, and the CPU would start executing the instruction that it finds there. And yes, so here we can type some text. Okay, program like this. So this is it from my side. Thanks for watching. Until next time, and take care.